Epoxy adhesives are chemical compounds used to join components by providing a bond between two surfaces. Epoxy adhesives were introduced commercially in 1946 and have wide applications in the automotive, industrial, and aerospace markets. Epoxies are probably the most versatile family of adhesives because they bond well to many substrates and can be easily modified to achieve widely varying properties. Because of their good wetting characteristics, epoxy adhesives offer a high degree of adhesion to all substrates except for some low surface energy, untreated plastics, and elastomers. Cured epoxies have thermosetting molecular structures. They exhibit excellent tensile shear strength, but poor peel strength unless modified with a more resilient polymer. Epoxy adhesives offer excellent resistance to oil, moisture, and many solvents. Low shrinkage on curing and high resistance to creep under prolonged stress are characteristics of many high-quality epoxy adhesives. Epoxy resins have no evolution of volatiles during cure and are useful in gap-filling applications. Composition of epoxy adhesives. Commercial epoxy adhesives are composed primarily of an epoxy resin and a curing agent. Various additives and modifiers are added to the formulation to provide specific properties. The curing agent may be incorporated into the resin to provide a single-component adhesive, or else it may be provided in a separate container to be mixed into the resin immediately before application. Epoxy adhesives are commercially available as liquids, pastes, films, and solids. Epoxy adhesives are generally supplied as 100% solids, no solvents or other volatiles, but some are available as sprayable solvent systems or water emulsions. Epoxy adhesives are also available in a wide range of chemical compositions, which allows for variations in how these materials can be applied and set, as well as variations in final performance properties within a joint. Cure temperature. Most commercially available epoxy structural adhesives are either single-component, also known as 1K, heat-curing adhesives, or multiple-component adhesives, typically 2 components or 2K, that cure at either room or elevated temperature. Generally, epoxy systems that cure at elevated temperatures have a higher cross-linking density and glass transition temperature than systems that are formulated to cure at room temperature. This provides the elevated temperature curing epoxies with better shear strength, especially at elevated temperatures, and better environmental resistance. However, they usually have poor toughness and peel strength due to their rigidity. Depending on the epoxy, resin, and curing agent used, room temperature curing adhesive formulations can harden in as little as several minutes at room temperature, but most systems require from 18 to 72 hours to reach full strength. The room temperature curing epoxy adhesives can also be cured at elevated temperatures if faster curing times are required. Once the curing agent is added to the epoxy resin, the adhesive must be used within a time period that is dependent on the resin and curing agent in the formulation and on the ambient conditions. With most room temperature systems, the time period is short, and the maximum time from mixing to application is considered the pot life of the system. For most single-component chemistries, the allowable time from mixing the hardener into the resin to application is relatively long and dependent on the storage conditions. This time period is defined as the adhesive's shelf life. An exothermic reaction occurs during the curing of epoxy adhesive systems. Exotherm is the heat that is self-generated by the curing reaction. If the exotherm is not controlled, it can lead to greatly reduced working life and even to a dangerous situation where the exotherm can be great enough to cause combustion. The exotherm can be minimized by reducing the reactivity of the mixed components and by limiting the batch size. Epoxy adhesives are often given a post-cure. Room temperature curing and elevated temperature curing epoxy adhesives are cured to a state in which the resin is hard and the bond is capable of handling strength. This provides the opportunity of releasing the fixturing used to hold the parts in place and moving the bonded component to the next manufacturing stage. Once the handling strength has been reached, the joint is post-cured without fixturing by placing it in an oven or other heat source until it achieves full strength. Often, post-curing can be combined with some other post-bonding process, such as paint curing or component drying. The epoxy adhesive manufacturer should be consulted in determining if post-curing is a viable option. B-staged resin. Many epoxy adhesives are capable of being B-staged. A B-staged resin is one in which a limited reaction between the resin and hardener has taken place so that the product is in a semi-cured but solid state. In the B-stage state, the polymeric adhesive is still fusible and soluble. On additional heat curing, the adhesive will progress from the B stage to a completely cured state. This will usually be accompanied by moderate flow. The advantage of B-staged resins is that they permit the formulation of one-component, solid adhesives such as films, powders, and preforms. The user can then purchase an adhesive product that does not require metering or mixing. There is very little waste associated with B-staged products, and they generally provide better consistency. The B-staged epoxy resins are formulated using curing agents, such as aromatic polyamines, along with solid forms of DGEBA epoxy resins. Secondary ingredients in epoxy adhesives include reactive diluents to adjust viscosity, mineral fillers to lower cost, adjust viscosity, or modify the coefficient of thermal expansion, and fibrous fillers to improve thixotropy, and cohesive strength epoxy resins are often modified with other resins to enhance certain properties that are necessary for the application. Often these modifications take the form of additions of elastomeric resins to improve toughness or peel strength. Industries using epoxy adhesives include aerospace, civil engineering, automotive, chemical, electrical, marine, leisure, and many others. The prevailing reason for the broad acceptance of epoxy resins in these important and diverse markets is their capacity to provide a good balance of handling characteristics and ultimate physical properties. They adhere well to a very large variety of substrates, and they generate tough, environmentally resistant films or matrices.